Assalamualaikum and hello everyone. My name is EFT2283 and I'm here to present our GIS project on timber production in Malaysia. Geography Information System or GIS is a powerful technology that allows us to collect, manage, analyze and visualize spatial data. It helps reveal patterns and relationship across different locations. In this study, GIS is applied to timber production data in Malaysia as a real-world case study, covering the duration from 2009 to 2070. This allows us to compare production trends over time. Each group members analyze timber production data from a specific year within the data set. For the analysis, we use two main GIS tools. First, desktop GIS, QGIS desktop. This open source software provides tool for spatial analysis, data visualization, and map production. It is highly suitable for environmental and spatial study, including timber production. Second, web GIS, QGIS2 web. This QGIS plugin allows us to create interactive web maps. Maps can be exported to web-based format and viewed via a web process, improving accessibility and sharing of our findings. By combining desktop GIS for detailed analysis with web GIS for interactive visualization, this project effectively examines the spatial distributions of timber production and highlights regional patterns across Malaysia, supporting better monitoring and decision making in forestry management.
To begin, install the latest release 3.4 of the QGIS application from the official download page. The administrative boundary data is sourced as the shapefile from the Humanitarian Data Exchange (HDX), and primary environmental data, specifically the production of major timber product statistic, is downloaded from the data.gov.my portal. Add an OpenStreetMap-based map to the project via the XYZ section on the browser panel. This base map provides the necessary geographic reference to ensure all data layers are accurately aligned. Import the COD-AB-MYS dataset from the unzip HDX shapefile to establish the official administrative border. Once imported, this layer appears on the canvas, allowing for spatial analysis of specific regions. Open the attribute table to inspect the database associated with the administrative boundary layer. Checking the table ensures that administrative data is correctly linked for future filtering or styling. Add the CSV file containing timber production statistic and join it to the boundary layer by adding a new field. This process connects the numerical data from data.gov.my to the specific states on the map. Apply graduated symbology to the layer using the timber production values. Select a color ramp and click Classify to divide the map into distinct data range. The resulting choropleth map displays varying production levels through a color gradient. This visualization allows for the immediate identification of high production versus low production regions. Use the QGIS2 web interface to select and export formats such as leaflet or open layers. Choose which data fields appears as interactive pop-ups and execute the export command. The resulting web map features interactive tools like zoom control, planning, and layer toggles. This interactivity clarifies the relationship between regional statistics and physical land use for the end user. Use the Quick OSM plugin to query land use and forest GIS directly from the OpenStreetMap database. Adding this layer provides a detailed visual comparison between actual forested area and official statistics. The plugin overlays forest vectors, points, and polygons on top of the state level timber data. This final visualization helps compare physical forest distribution across Malaysia with reported output.
Application to environmental or spatial problem. First, timber product 2050. There are 3 states that recorded this year. Sarawak is the highest recorded, which is 6560731 to 8200719. While the state of Pahang and Sabah recorded the same record, which is 1640767 to 3280755. Timber product 2009. Sarawak state has the highest value, which is 8296911 to 10371139, while Sabah is not too high, 6222 683 to 8296911. Timber product 2040. There are 2 data for this year. First, the data for the state of Sarawak, which is the highest 6973019 to 8716098. Next, for the state of Sabah, which is 1743782 2348681. Timber products 2017. For this year data, the same value was recorded for the state of Pahang and Sarawak, which is between 589291 to 736614. Last, timber product 2011. The data for the state of Sarawak is the highest, which is between 7688439 to 9610434.
Comparison and evaluation. There are 3 aspects. First, desktop GIS and web GIS. Second, vector and raster data. And third, 2D GIS and 3D GIS. Advantage: desktop GIS, big data analysis and full data control. Web GIS, easy accessible. Disadvantage: desktop GIS, not very collaboration and require installation. Web GIS, limited functionality and require internet depend. Second, vector and raster data. Advantage: for vector, easy to update, and raster suitable for satellite image and survey modeling. Disadvantage: vector is not suitable for continuous data. Raster is required large storage, less accuracy location specific. And third, 2D GIS is easy for navigation and basic analysis, and 3D building analysis, topography and urban planning. Where the disadvantages is 2D less realistic and 3D more complex, require high computer resources. Thank you.
Several important digital and GIS skills. First, I work with spatial data by importing different types of data, such as shapefiles, raster images, and online-based map. I also use attribute tables to view and filter information based on specific criteria. Next, I manage multiple map layers, including layers such as rivers, land use, and risk area. I adjusted the layer order, visibility, and transparency to make the map clearer and easier to understand. I also focus on symbology and map design. Different colors and symbols were used to represent various features and levels of risk. Labels, legends, scale bars, and north arrow were added to improve map readability. and presentation quality. Analysis, I use basic GIS tools such as buffer and overlay analysis to identify spatial relationships. This helped me understand how different areas are affected by the environmental issue being studied. Finally, I demonstrated web GIS skills by publishing or simulating an interactive web map. Users can zoom, click on features, and view information through pop-ups, making the map accessible and user-friendly. Overall, this project helped me develop technical, analytical, and digital mapping skills while showing how GIS can be used to support real-world decision-making.
In conclusion, the project successfully mapped and analyzed timber production patterns in Malaysia from 2009 to 2017 using GIS, employing a two-step workflow where desktop GIS, QGIS, facilitated detailed spatial analysis to identify production patterns, and web GIS, QGIS to web enable the creation of interactive map for easy visualization and sharing, through which the team developed key GIS skills, including data management, spatial pattern analysis, thematic and choroplane mapping, and web map publishing, leading to the observation that desktop GIS is highly effective for in-depth analysis, while web GIS enhances accessibility and communication of results, and ultimately recommending a hybrid approach of using desktop GIS for true analysis and web GIS for presenting findings interactively, with the interaction of both providing valuable insight into timber production trends and supporting better planning and inform decision making in forestry management.